Hello all. Welcome to the lecture series on probability theory and stochastic processes. In this lecture, we concentrate on problems on wide sense stationarity. It is known after studying much about random variables, random process came into picture. A random process is generally defined as a random variable with time added to it. Okay, if x is a random variable, okay, if x is a random variable, correspondingly, we can represent a random process as x of t, right? Because random variable, if changing as a function of time, we call it. Okay, and the number of ways to define also, right? Okay, this is the way to represent. We can write like x of t, we can write, or x of s comma t, also we can write to represent the random process. Number of random process exist: continuous random process, continuous random sequence, discrete random process, discrete random sequence. This classification is based on how time and the random variable take values. Random process can be further classified based on the stationarity, that is one parameter. Second one is statistical independency, and third one is ergodicity. So these are the ways to classify the random process in another manner. So once we know different types of random process, what the way they are existing, we can concentrate much more on stationarity. Why? Because stationarity is playing a crucial role in the performance evaluation of communication systems. For analyzing any system, generally what we assume that it is stationary. So when we call specific system or specific signal as stationary is very important. Unless we assume this stationary or apply stationarity concept to real-time systems, we cannot carry out the analysis. So after talking about the random processes, now let us discuss more about stationary processes. So what is the meaning of stationary or stationarity? If the statistical properties does not change with time, if the statistical properties does not change with time, we call the random variables or the random processes as stationary, right? A random process is said to be stationary if its statistical properties does not change with time. What is the meaning of statistical properties? Whatever parameters you can estimate using the expectation operation. Whatever parameters like mean value, like autocorrelation, etc. Number of stationarities were existing, like a first order stationarity, second order stationarity, nth order stationarity, etc. Okay, so first order, you can write second order and nth order. First order, second order, and so on, nth order. These are the multiple ways to define stationarity. Okay, so a random process is said to be first order stationary if its first order density function does not change with time. A random process is said to be first order stationary if its first order density function does not change with time. Then immediate doubt comes. What is the meaning of first order? First order means it involves only one time instant or one random variable. If this first order density function does not change with time, it is first order stationary. Similarly, second order stationarity. How to define? Simple, no? If the second order density function does not change with time, it is said to be second order stationary. X1 comma x2, t1 plus delta t comma t2 plus delta t. What is delta t? A small increment in the time. So if you have observed here, even though x1, x2 are constant, time is changed. At t1, this is okay, comma, t1 comma not plus, please. This is t1 comma. Even though time, this is t1, this is t1 plus delta t, this is t2, t2 plus, even though time is changed, the random variable values are not changed. Okay, so this is second order stationary. Similarly, in the case of nth order stationary, what is nth order? There exist n random variables, xn, okay, t1 comma, t2, etc., tn, which is independent of time. So x1 comma, x2, etc., xn, semicolon, t1 plus delta t, time is changed, t2 plus delta t, time is changed, etc., t n plus delta t. Even though time is changed, the random variable values are not changed. This is called as nth order stationary. Clear? So stationarity is going to be defined under number of orders. Here, order means number of random variables involved. First order density function contains one random variable. Second order density function contains two random variables. And nth order density function contains n random variables. Okay. So a random process that is second order stationary is also be called as wide sense stationary. Okay. A random process which is a second order stationary can be called as wide sense stationary. Okay, so for wide sense stationarity, these two are the conditions. One is mean value must be constant. Second one is autocorrelation function is constant. This is definition of autocorrelation. Rxx of t1 comma t2 equals to E of x of t1. It means x1. X of t2 means t2. So autocorrelation function should depend only on the time difference, but not on time t. If these two conditions are satisfied, we say the random process is wide sense stationary. Now, with this fundamental rule for stationarity defined, a couple of examples are to be solved for getting much knowledge about the stationarity. So, this is example one. Okay. Okay, this is example one. It is given as the random process is defined as capital X of t equal to A, where A is a uniformly distributed random variable. So, what is the objective now? We need to estimate E of X of t equals to what is the expression generally for expectation operation? X of t into fx of x dx. But in the given example, what is the random variable? A. So, minus infinity to infinity, x of t into fa of a dA. So, I substitute 0 to 1. X of t is a. What is fa of a? 1 by b minus a. Uniform density function. 1 by 1 minus 0 equal to 1. So, this is fa of a. So, a into 1 into dA. What's the integration of 1? A square by 2, whose value 1 to 0 will be 1 by 2. So the mean value is 1 by 2, constant, independent of time. So first condition satisfied. And what is second condition? Autocorrelation function. So autocorrelation function Rxx of t1 comma t2 equal to E of x of t1 x of t2 equal to, yeah, let us go same manner, 0 to 1. What is x of t1? A. What is x of t2? Again A. Actually, this should be x of t plus tau. But the given function does not contain t, no. So A into fa of a. So 1 dA. So this is equals to a square 0 to 1 dA. What is the integration? A square is a cube by 3 because you are integrating with respect to capital A, it is a cube by 3. So value is 1 by 3. We should not stop the problem here itself. We have to mention the statement also. What is it? As the mean value is constant, as mean value is constant, mean value and of course autocorrelation also, as mean value and autocorrelation are constant, given random process x of t is wide distance station. Okay, this is one manner. So in this example, the existence of random variable is seen. The problem is consisting of one random variable. So one more is similar, one more. So how to proceed? Let us see. In this case, theta is the random variable. Okay. So let's continue. Same thing. This is 2. So what is required? First one is mean must be constant, equal to limits okay, minus infinity to infinity x of t into what is random variable here? Theta. So f theta of theta d theta. What is f theta of theta d theta? Uniform function. So 1 by b minus a equal to 1 by 2 pi minus 0. So density function is 1 by 2 pi. So simply mean value E of x of t equal to x bar equal to 0 to 2 pi a cos omega naught t plus theta. A is a constant and omega is a constant d theta. Okay, in by 2 pi. Why? Because we have substituted density function now. So a by 2 pi outside, integration of sine is cos is sine. So it will be sine omega naught t plus theta. Limits are 0 to 2 pi equal to 0. Mean value 0. So first condition satisfied. Similarly, second one, what we have to estimate? We have to estimate the autocorrelation function, right? So first let us write the expression for autocorrelation function and then continue doing. Okay. So Rx of T1 comma T2 equal to E of x of T1 x of T2 equal to minus infinity to infinity x of T1 x of T2 f theta of theta d theta. What is T1? T. What is T2? T plus tau. We have substituted. This is equal to 0 to 2 pi a cos omega naught t plus theta into a cos omega naught t plus tau plus theta into 1 by 2 pi. This is density function no d theta. So this will be equal to, outside we take out a square by 2 pi. So we multiply and divide by 2. So 1 by 2 into 0 to 2 pi 2 cos omega naught t plus theta cos omega naught t plus tau plus theta d theta. Okay, right? So now we have to simplify 2 cos A cos B, cos A plus B, cos A minus B. It is known, right? So we could just do that one also here. This is equal to a square by 2 into 1 over 2 pi 0 to 2 pi cos A plus B cos of 2 omega naught of t 2 omega naught t plus this is t plus omega naught tau plus 2 theta, right? Omega naught t, omega naught t, 2 omega naught t, omega naught tau plus 2 theta. This is okay, plus a minus b. So what will be left over? Omega naught plus it will be equal to cos of omega naught tau d theta. So no need to take much pain. First term will be 0 because integration of cos is sine. And second one, because of theta we have to do. So a square by 2 into integration of this will be 0 to 2 pi theta cos omega naught tau into 1 by 2 pi. Why 1 by 2 pi? Already it is there. So it will be equal to a square by 2 into 1 by 2 pi, 2 pi minus 0 into cos omega naught tau. 2 pi cancel. Value is a square by 2 into, okay, value is this, value is a square by 2 into cos omega naught tau. A square by 2 into cos omega naught. So again, as the mean value is constant, as the autocorrelation function is constant, what is the meaning of constant? It is independent of time. Constancy indicates that independent of time. That is stationary. No? Stationarity means the values, the statistical properties, the mean value, the autocorrelation function, etc. must be independent of time. So conclusion is, as mean value and autocorrelation function are independent of time, given random process x of t is wide sense stationary. So this is another variety of problem. Okay. Similarly, let us go with a little typical one further, because always we are not going to be consisting of a single random process. Sometimes we may have multiple random processes also, like this example. Okay, so in this example, see this. Two random processes are given. One is x of t, second one is y of t. Whether they are jointly stationary or not. So what is required for this? For jointly wide sense stationarity, mean value must be constant, followed by the mean value of y of t must be constant, followed by the cross correlation function must be constant. This is the difference between earlier sums and this sum. So Rx y of E of, not E of, okay, Rx y of, okay, what is T? T will be T1. This is T plus tau. This should be equals to Rxy of tau, independent term. How to estimate this? This is nothing but E of x of T1 and y of T2, where T1 is T and T2 is T plus tau. Okay. So with that in mind, let us estimate the individual means first of all. What is E of x of t, and then go for E of y of, whether they satisfy the condition or not. See, E of x of t, okay, x of t was given, y of t was given, okay, 0 to 2 pi, right? So let us proceed for the first one. Estimate E of x of t. So as usual, 0 to 2 pi are the limits given, x of t into fx of x dx. So actually this should minus infinity. In the definition, it must be minus infinity. Replace them later. So 0 to 2 pi. What is the random variable? Theta. So x of t into f theta of d theta. Just now we have estimated what is f theta of theta in the interval 0 to 2 pi. It is 1 by 2 pi, uniform function, right? So we can directly go like this. Given function is a cos omega naught plus theta. So 0 to 2 pi a cos omega naught t plus theta into 1 by 2 pi, because this is f theta of theta d theta, close. So this is equal to a by 2 pi outside, integration of 0 to 2 pi cos is sine omega naught t plus theta. This is 0. Okay, so a of x of t is 0. Similarly, what is a of y of t also? We need e of, expected value of y of t. So this is e of y of t equal to, same manner, let us go directly 0 to t pi, given what is the function? B sine omega naught t plus theta. B sine omega naught t plus theta. Density function is uniform, 1 by 2 pi. He has mentioned. So this will be B by 2 pi. Integration of sine is cos, 0 to 2 pi minus cos, of course, minus cos omega naught t plus theta. Upper value is 2 pi, lower value is 0, again value is 0. So mean of x of t is 0, mean of y of t is 0. So first two conditions are satisfied, right? So we need to go for the second condition. What is it? The cross correlation function must be independent of time. Let us see that. Okay. So cross correlation function equal to Rxy of t comma t plus tau equal to, so x of t, right? Second one, y of t plus tau. This is to be remembered very much. X of t, y of t plus tau. This is equals to limits as usual 0 to 2 pi. X of t is a cos omega naught t plus theta. Y is b of b into cos omega naught t plus tau plus theta. Density function is 1 by 2 pi d theta. So a b, okay, we just proceed further. Okay, so a b by 2 pi into 2 by 2, so 0 to 2 pi 2 cos omega naught t plus theta. This is second one sine, right? So sine omega naught t plus tau plus theta d theta. So 2 cos A sin B. So in this case, we have to represent the given into sum of cosines or sum of sines, right? So then replace cos A sin B and proceed further. Substitute that in terms of cos and sine. So it will be sin A plus B minus sin A minus B, right? So we have to use that. 2 cos A sin B can be given as sin A plus B minus sin A minus B, which will be correspondingly equal to AB by 2 into 1 by 2 pi, okay, 0 to 2 pi sin A plus B means 2 omega naught t plus omega naught tau plus 2 theta. In the previous sum also, we have to put 2 theta. I think we have taken theta only. Take care of that one. Minus sin A minus B. A value is omega naught plus theta. B value is this. So this will be equals to minus half minus plus. This will be sin omega naught tau d theta. Right? So just refer the previous sum ones. There also we have to get 2 omega naught t plus omega naught tau plus 2 theta. Let me just verify. Anyway, the answer is not going to change. So where we have taken in the previous case is, yeah, I think this one. 2 theta we have mentioned, right? Right, okay. Same is the case. Right? Okay, now we have to simplify further. This is equal to AB by 2 into 1 over 2 pi integration of sine is minus cos. So minus, okay, you put minus here, minus cos 2 omega naught t plus omega naught tau plus 2 theta by 2 plus theta into sine omega naught tau. This value is anyway 0. Cos of 2 pi, cos of 0. So value 0. Here, in the place of theta, we have to substitute 2 pi minus 0. So it is 2 pi. So value is AB by 2 into 1 over 2 pi. One over 2 pi. Okay. Two pi sine omega naught tau. 2 pi cancel. So finally, AB by 2 sine omega naught tau. So again, mean values, individual means E of x of t, E of y of t are constant, as well as the cross correlation function also constant. So again, it is what you have to mention, given x of t and y of t are jointly wide sense stationary, right? So these are the few examples on wide sense stationarity. Point to be observed here is in the sums solved here, the given random process contains a random variable that is mostly uniformly distributed. But when it is not mentioned, it is not specifically given what type of distribution is used, the way of solving the problem will be different. So such examples we see further in the upcoming lectures. Okay, let us discuss in detail about them later. Thank you.